We're gonna learn about now fundamentals of machining. In this chapter, we're gonna cover fundamentals of machining, basic concepts, chip formation, and types of chips produced in cutting. The parts that we have shaped with casting or rolling or forging, they often require further operations, what we call secondary operations. Why do we need secondary operations? We might need a smooth and shiny surface. We might need sharp features on our part, or small diameter holes, threaded sections, threaded holes. So machining processes consists of removal of material and modification of a workpiece. Machining processes remove material from the surfaces of a workpiece by producing chips. Here are some common cutting processes: turning, cutting off, slab milling, and milling. What is turning? The workpiece is rotated and the cutting tool removes a layer of material as the tool moves along its length. Let's see the image here. We can see that the workpiece is being rotated and the cutting tool here removes a layer of material as the tool moves along its length. Tool is moving. Okay, this is turning. And then cutting off. The tool moves radially inward and separate a piece from blank. So we can see that the tool moves radially inward. This one goes inward, okay, and separates a piece from blank. Okay. And we see that workpiece is rotating. So make sure you, from the images, you understand what type of machining operation it is. So if I give you the image, you understand that is turning, that is cutting off, etc. So the next is slab milling. In this case, a rotating cutting tool removes, here rotating cutting tool removes a layer of a material from the surface of the workpiece. So this is working on the surface, right? And the cutting tool, the cutter, is rotating and the workpiece is moving towards this direction, and we remove material from the surface. And there is end milling. A rotating cutter, again here rotates, right? And this travels to a certain depth. We are seeing certain depth in the workpiece, producing a cavity. Okay, so this produces a cavity. And this one is removing surface material, right? Now let's take a look at understand the factors that influence the cutting operations. So there are independent variables, meaning it doesn't depend on anything. So these variables will change the cutting operation, will affect the cutting operations. And which ones? For example, tool material and coatings, tool shape, its surface finish and sharpness. You can expect these to affect the cutting process, right? Workpiece material and its processing history, meaning what type of a material you are working on, and is it heat treated? Does it have a hard surface? What is the hardness? Is it brittle? Those types of things affect cutting process. Cutting speed, feed, and depth of cut. Cutting fluids, if any fluid you are using, that will also affect the process. Characteristics of the machine tool. The type of work holding device and fixturing. So meaning when you are doing, how do you fix your material while working on it. Those are all factors that are affecting the cutting process. And we are not going to cover all of them, and some of them we're going to cover. There are also dependent variables, meaning they depend on the independent variables listed previously. For example, type of chip produced, force and energy dissipated, temperature rise in the workpiece to tool and the chip, tool wear and failure, surface finish after machining. So these are gonna depend on the independent variables. For example, tool wear and failure, right? If you go back, it will depend on the tool material, coatings, tool shape, surface finish. It will depend on these. It will also depend on workpiece material, its processing history, and cutting fluids, all of them nearly. Or temperature rise in the workpiece, the tool and the chip. It can depend on cutting speed, for example, or the workpiece material, or the characteristics of the machine tool. So these dependent variables are the independent variables are influenced, affected by the independent variables. This table just summarizes the factors influencing the machining operations. So we're gonna see different type of chips that produced cutting speed, depth of cut, temperature rise, tool wear, machinability, how these are affected and influence the machining operations. For example, temperature rise, it will influence tool life, dimensional accuracy of workpiece, and may cause damage to workpiece surface. Tool wear, it will influence surface finish, dimensional accuracy, temperature rise. So machining is actually a rather complex process where there is a lot of relationship between different parameters. So, for example, your machining yield unacceptable results. For example, the surface finish is unacceptable. So then, which independent variable should be changed? So if your surface finish is not desirable, which of these you should change because they depend on these independent variables. Should you change the tool shape, its surface finish? So one of these variables are affecting your surface finish. And cutting tool wears rapidly and becomes dull. So what could it be? Maybe you need to choose another type of cutting tool. Cutting tool material may be affecting your process. The tool begins to vibrate. So there might be a problem then in your type of work holding device and fixturing. So if you observe that your workpiece becomes hot, maybe there is tool wear and you need to choose the correct tool materials and coatings. So always you observe your process and figure out what is wrong, what is the unacceptable result you are observing. Then these will be a result of problems in the independent variables. So you come back to here and figure out what is wrong with which of these independent variables. Then you try to fix the issue. Now let's take a look at types of chips produced in cutting. So there are 4 types. One of them is continuous chips. So these are generally formed from ductile materials. Machining at high cutting speeds, and they are not desirable because they tend to tangle around the tool, the workpiece, and the fixturing. So if we take a look at the images here, in image A, we are seeing a continuous chip with narrow, straight, and with the primary shear zone here. So this part is being the chip, this part here, and it is also shown here. And your tool comes here like that, trying to remove material from the workpiece. And this is the shear zone, right? Material is sheared. And since this is a continuous chip, as we talked, it can create undesirable effects, like they tend to tangle around the tool, the workpiece, and the fixturing. The second type of chips produced in cutting, build-up edge. Build-up edge, BUE, consists of layers of material from the workpiece that gradually deposited on the tool tip. So let's take a look at the image. You see image C is showing you the build-up edge here. So this is your tool right there, okay? And as you can see, material from the workpiece, okay, this is the workpiece, and it is deposited on the tool tip right there. And that is the reason it's called build up. Okay. It is removing the chip. Chip is here, right? As it grows larger, the build-up edge becomes unstable and eventually it breaks apart. And as you can see, the build-up edge it changes the geometry of the cutting edge. This image B is also showing us there are shear zones forming during the removal of the material from the workpiece. You see this part is primary shear zone, and you can see the layers. And this part you can also see this is the secondary shear zones. Okay. And as you can expect, the build-up edge is a major factor that adversely affects surface finish. So the tendency to form build-up edge can be reduced if we increase the cutting speed, decrease the depth of cut, use a sharper tool, use an effective cutting fluid. So there are factors that can be used to reduce the formation of the build-up edge. The third one is serrated chips, or it can be also serrated or segmented chips. These are semi-continuous chips with large zones of low shear strain and small zones of high shear strain. So let's take a look at it. So in image D, we are seeing it. As you can see, it is not continuous like this one. It is semi-continuous like this. And it has large zones of low shear strain here. And then small zones of high shear strain at the tips. Metals that have low thermal conductivity and strength that decreases rapidly with temperature exhibit this behavior. So if you have a material where its strength is decreasing with temperature, we call thermal softening. Or if you have a material with low thermal conductivity, these type of metals show serrated or segmented chips. One example is titanium. And the last one is discontinuous chips. And as you look at the image, you understand, right? The chips are like discontinuous, like this. You can see. Okay. So here is your tool coming here and removing the surface. And usually, by definition, this is consists of loosely attached segments, and we have seen this in the image. Also, when this type of chips observed when you have brittle workpiece, because they don't have the capacity to undergo the high shear strains encountered in machining. Also, the materials, the workpiece materials that contains hard inclusion and impurities, they show discontinuous chips. Let's now learn about chip curl. So chips develop a curvature as they leave the workpiece surface. And this is called chip curl. Even in you are working with a metal, non-metal, the chips will develop a curvature. And the factors affecting that are work hardening characteristics of workpiece, the geometry of cutting tools, processing parameters, cutting fluids. So if we look at the process parameters, how they affect, the depth of cut, as the depth of cut decreases, the chip becomes more curly. So depth of cut is illustrated here. This is the depth of cut. So if this is the tool, this is the chip that is forming. This is the tool tip, and the part is rotating, right? And how deep we go cutting the part is the depth of cut. And as it decreases, the chip becomes more curly. And also cutting fluids makes chips more curly. So we have discussed that chips they are undesirable, especially continuous long chips, because they tend to entangle and interfere with the machining operation, and therefore they also become a potential safety hazard. Therefore, there are some features added to cutting tools, and these are called chip breakers. So chip breakers, they are to break the chip intermittently with special features on cutting tools, and these are the chip breakers. So in image A, we are seeing machining of aluminum using an insert but without a chip breaker. So you can see the long chips that can interfere with the tool and present a safety hazard you are seeing here. And in image B, we are seeing we don't even see those chips anymore, because this is machining of aluminum with the chip breaker. So there is also illustration of the action of the chip breaker, as we are seeing in image C. There is your tool, there is the chip breaker put here like this one, and you see the chip without the chip breaker like this, but with the chip breaker it's shorter, it's breaking it. Okay, so illustrations for those are given to us. In summary, we have learned the basics, and we have learned different types of chips, and we have learned that how we can prevent the chip curl and chip formation. And that's all we're gonna cover for this chapter.